In this video, we're going to learn how to give our program data and explain to the program what we would like it to do with the data that we have provided. So for example, if we have a whole list of numbers that we want the program to add up or work out the average of, we can provide those numbers and write a piece of code that does the math, which the program can then run and actually do the math for us. Or if we want to work out the area of a 2D or a 3D shape, volume, a lot of the math that is required in STEM type projects can be done by writing a piece of program, a piece of software that does that for you. So we're going to start off with a simple example. We're going to start off with writing a program that takes in two numbers. So the user, whoever's working on the program, provides the two numbers, say 10 and 15, and the program's job is to add them up and print the results to the screen. To do this, the main concept to understand here is inside a computer program, the information that you give, the data that you give to a computer, needs to have some kind of a holder, a box, in which the data can be stored. And these boxes are called variables. They're called variables because the information that you can put into them can vary. It can change. It's not specific. So for example, if you want to add a few numbers, those numbers can change every time you run the program. So on the screen here, let's say we create a variable and we give the variable a name. In my case, I've called it num1. The reason you want to give the variable a name is because then you can use that name in a formula later on when you explain to the program what you want it to do with that number. Because I want to add up two numbers, I'm going to now then create a second variable, which shows up as a box on my screen here, and call it num2. Now, these two numbers, the program will know what num1 is and what num2 is, so later on I can say to the program, now please add up these two numbers for me. So I can create a third box, which I'm going to call sum here, and I can specify that what I mean by sum is num1 plus num2. So this is the basic structure. I have variables, I've given them names, and then I have a formula explaining what I want the program to do with those variables, and I've also given the a space for the program, a variable, a box for the program to put the result into. Now, just a quick word about naming variables. When you name variables, it's good practice to use lowercase letters for the first part of a name, so in this case all lowercase n and s. But if your variable has a two-part name, such as sum of two numbers, the second word begins with an uppercase letter. So if I had a variable name called average math, average would be lowercase, math would be uppercase, and any word that followed math would also have uppercase as its first letter. This is called camel casing, and it just makes it easier visually for someone to read the name of a variable and figure it out. If you had everything lowercase and everything uppercase, it would just be really hard to read. So that's good practice, and it's also good practice not to start a variable name with a number. That would generate an error. So let's look at how we would actually write this program. I'm going to go to Replit, and the first thing I'm going to do is I'm going to print a message that says, please enter the first number. Now, this will generate a message on the screen. Once this message runs, and you can hit run and test that it runs. Now, what I need to do is I now need to figure out how am I going to take the number that the user has inputted and put it into a variable. So to do this, what I'm going to do is, first of all, I'm going to go and before the message is generated, I'm going to write a piece of code that says to the program, I want to create a variable called num1, and I want you to be able to store integers. An integer is a whole number, and in C++ integers are written as int. Int num1, semicolon. This line simply says to the program, I would like you to create a variable, a box. At this, in this instance, the box is empty. A box called num1, and it should be able to store integers. I'll also just say to it, I want you to create a second box, which also should hold integers or whole numbers, and I want you to call it num2. Now, once I specify, let's do a \n here so that line ends. Once I output a message that says, please enter the first number, what I want to do is I want to take that first number that the user is entering, and the user can enter anything, 5, 10, 25, -30, whatever they want. I want to take that number and put it into that first box that I've called num1. And to do that, what I need, and let's add using namespace std here so we don't forget, I'm going to come back and I'm going to do a cin. A cin is short for read-in, cin num1. This cin refers to reading in, taking into the console whatever the user has typed and putting it into num1. So this line, line 7, is saying to the program, the user is going to type something at this point after they've read this message. I want you to take that number and put it into the box num1, is what that line is saying. Now we can remove the std here. So now the user will have inputted a number and the computer will have stored it into num1. I want to repeat this process because I want a second number. So I'm just going to copy and paste that code. And here I'm going to change this to please enter the second number. Now the user will enter another number, but if I'm not careful, if I don't make the changes, the second number that the user inputs will at this point go and be stored in num1 again. So it will overwrite and delete that first number. So I have to make sure this is now num2. So the second number will now be stored in num2. So far, you won't see anything happening on the screen because this is all happening in memory. So now, again in memory, you're going to say, okay, good. So hopefully you've read in those two numbers, you've stored them. Now I want you to take those two numbers and add them up and put them into a third box that I'm calling sum. The way you write that is sum equals num1 plus num2 semicolon. Now what you will notice is we haven't actually told the program what sum is. Anytime you create a variable in C++, you have to tell the program, is that a number? Is that a letter? What is it? So I'm going to go back and I'm going to specify that sum is also an integer. Because sum is the addition of two integers, it is also an integer. So at this point, at line 11, it should do the math. And then sometimes you'll have students say, well, I'm doing everything and nothing's happening on the screen. And as you can probably figure out, what's missing here is asking the program to print the result. So far, it has probably done all the math in the background, but we cannot see anything on the screen because we haven't specified that it print the number to the screen. So I'm going to now say cout sum and line, and let's run that and see what happens. So please enter the first number. Let's do 7. Please enter the second number. Let's do 10. And the result I get is 17. So it did the math for me. Now it's good practice when you're doing this to put something before sum here that tells you that that is the sum. So what I'm going to do is I'm going to go back to that last line, and in quotation marks I'm going to say sum colon, close the quotation marks, and put another set of less than signs. And what this is going to do is it will literally print the word sum and then print the value of sum after that. So now when I run the program, 6, 20, the sum is 26. So what's happened here is this sum within quotation mark is read literally, so the program knows that I want the exact word sum with colons to be printed. But this sum here is not in quotation marks. So the program knows that here I don't want the literal word sum, I want the value of sum to be printed. So when we want to print something that is inside a box, inside a variable, we write the name of that variable without quotation marks, and C++ understands that to mean that you want that value to be printed. Now, with this system, this is the basic structure of writing a program that will do most of the math that you require a program to do. You can use the same system, let's say, to work out the area of a triangle. If for the area of a triangle you need the triangle's base and height, and then you have the formula to work out the area, you would simply say, please enter the base and take in that number and give it a sensible name like base. Please enter height, and then the user would enter that number and you would store it in a variable called height, and then you would write the formula for what you want the program to do with this information, and then you would just print it out. That is the basics of creating integer variables. One last point here is sometimes the data that you provide to a program is not whole numbers. Sometimes it is decimal numbers. If that happens, what you need to do is change ints into floats. Floats are understood to be decimal numbers. Now in this program, if I were to change all the ints into floats, that's a singular, not plural, and change that into a float, and if I were to run this program again, I would now be able to put in decimal numbers. So if I say, okay, what are the two numbers you want to add? I want to add 6.5 and 1.5, and it says, well, that's an 8. It added the decimal numbers. If I were to try to add 6.5 and 1.5, but specify the variables as integers, what the program would do is it would take the 6.5 and read it as a 6 only, and the 1.5 and read it as a 1 only, and completely ignore the decimal and add them up to a 7. So that's why if decimal values are important, you want to make sure that you specify that your variables are floats and not integers. So to sum up, when you have data, in this case mathematical data that you want to give to your program, create variables, read the data in, put them inside the variables, and then explain to the program what math you want the program to do with the variables, and finally print out the results.